electric current from the power station, and the third is earth by connecting it to the buried metal plate. Metallic bodies of the electric appliances such as electric iron, refrigerator, TV are connected to the earth wire. When any fault occurs or live wire touches the metallic body, the charge flows to the earth without damaging the appliance and without causing any injury to the humans. This would have otherwise been unavoidable since the human body is a conductor of electricity. Charging by induction. When we touch a pith ball with an electrified plastic rod, some of the negative charges on the rod are transferred to the pith ball and it also gets charged. Thus the pith ball is charged by contact. It is then repelled by the plastic rod but is attracted by a glass rod which is oppositely charged. However, why an electrified rod attracts light objects is a question we have still left unanswered. Let us try to understand what could be happening by performing the following experiment. I bring two metal spheres, A and B, supported on insulating stands, in contact as shown in Fig. 1.4a. Bring a positively charged rod near one of the spheres, say A, taking care that it does not touch the sphere. The free electrons in the spheres are attracted towards the rod. This leaves an excess of positive charge on the rear surface of sphere B. Both kinds of charges are bound in the metal spheres and cannot escape. They, therefore, reside on the surfaces, as shown in Fig. 1.4b. The left surface of sphere A has an excess of negative charge and the right surface of sphere B has an excess of positive charge. However, not all of the electrons in the spheres have accumulated on the left surface of A. As the negative charge starts building up at the left surface of A, other electrons are repelled by these. In a short time, equilibrium is reached under the action of force of attraction of the rod and the force of repulsion due to the accumulated charges. Fig. 1.4b shows the equilibrium situation. The process is called induction of charge and happens almost instantly. The accumulated charges remain on the surface, as shown, till the glass rod is held near the sphere. If the rod is removed, the charges are not acted by any outside force and they redistribute to their original neutral state. Separate the spheres by a small distance while the glass rod is still held near sphere A, as shown in Fig. 1.4c. The two spheres are found to be oppositely charged and attract each other. Remove the rod. The charges on spheres rearrange themselves as shown in Fig. 1.4d. Now, separate the spheres quite apart. The charges on them get uniformly distributed over them, as shown in Fig. 1.4a. Figure 1. 4. Charging by induction. 6. In this process, the metal spheres will each be equal and oppositely charged. This is charging by induction. The positively charged glass rod does not lose any of its charge, contrary to the process of charging by contact. When electrified rods are brought near light objects, a similar effect takes place. The rods induce opposite charges on the near surfaces of the objects and similar charges move to the farther side of the object. Electric charges and fields. This happens even when the light object is not a conductor. The mechanism for how this happens is explained later in sections 1, 10 and 2. 10. The centers of the two types of charges are slightly separated. We know that opposite charges attract while similar charges repel. However, the magnitude of force depends on the distance between the charges and in this case the force of attraction overweighs the force of repulsion. As a result, the particles like bits of paper or pith balls, being light, are pulled towards the rods. Example 1. How can you charge a metal sphere positively without touching it? Solution. Figure 1. 5a shows an uncharged metallic sphere on an insulating metal stand. Bring a negatively charged rod close to the metallic sphere, as shown in Fig. 1.5b. As the rod is brought close to the sphere, the free electrons in the sphere move away due to repulsion and start piling up at the farther end. The near end becomes positively charged due to deficit of electrons. This process of charge distribution stops when the net force on the free electrons inside the metal is zero. Connect the sphere to the ground by a conducting wire. The electrons will flow to the ground while the positive charges at the near end will remain held there due to the attractive force of the negative charges on the rod, as shown in Fig. 1.5c. Disconnect the sphere from the ground. The positive charge continues to be held at the near end. Fig. 1.5d. Remove the electrified rod. The positive charge will spread uniformly over the sphere as shown in Fig. 1.5a. Figure 1.5. In this experiment, the metal sphere gets charged by the process of induction and the rod does not lose any of its charge. Similar steps are involved in charging a metal sphere negatively by induction, by bringing a positively charged rod near it. In this case, the electrons will flow from the ground to the sphere when the sphere is connected to the ground with a wire. Can you explain why? 5 basic properties of electric charge. We have seen that there are two types of charges, namely positive and negative, and their effects tend to cancel each other. Here, we shall now describe some other properties of the electric charge. If the sizes of charged bodies are very small as compared to the distances between them, we treat them as point charges. All the charge content of the body is assumed to be concentrated at one point in space. 1.5. Additivity of charges. We have not as yet given a quantitative definition of a charge. We shall follow it up in the next section. We shall tentatively assume that this can be done and proceed. If a system contains 2 point charges Q1 and Q2, the total charge of the system is obtained simply by adding algebraically Q1 and Q2, i.e. charges add up like real numbers or their scale is like the mass of a body. If a system contains n charges Q1, Q2, Q3, Qn, then the total charge of the system is Q1 plus Q2 plus Q3 plus Qn. Charge has magnitude but no direction, similar to mass. However, there is one difference between mass and charge. Mass of a body is always positive, whereas a charge can be either positive or negative. Proper signs have to be used while adding the charges in a system. For example, the total charge of a system containing 5 charges plus 1, plus 2, minus 3, plus 4 and minus 5, in some arbitrary unit, is plus 1 plus 2 plus minus 3 plus 4 plus minus 5 equals minus 1 in the same unit. 1.5. 2 charge is conserved. We have already hinted to the fact that when bodies are charged by rubbing, there is transfer of electrons from one body to the other. No new charges are either created or destroyed. A picture of particles of electric charge enables us to understand the idea of conservation of charge. When we rub two bodies, what one body gains in charge the other body loses. Within an isolated system consisting of many charged bodies, due to interactions among the bodies, charges may get redistributed, but it is found that the total charge of the isolated system is always conserved. Conservation of charge has been established experimentally. It is not possible to create or destroy net charge carried by any isolated system, although the charge-carrying particles may be created or destroyed in a process. Sometimes nature creates charged particles. A neutron turns into a proton and an electron. The proton and electron thus created have equal and opposite charges, and the total charge is zero before and after the creation.